All right, pre-calc, let's do this. Welcome. Game plan for today will be transformations of functions. So let's do a little bit of a review from last class. Here, what were the certain types of parent functions we learned about? We actually didn't go over this one, a constant function. I'll go over this one very soon. But for sure, we did the graph of x squared. So it has some quadratic look like this. We did f of x equals x, so y equals x is a linear graph like this. Here, I did not show you a cubic graph, if I have x to the 3, but the graph would look something like this, right? You'll have, as x goes to positive infinity, your y is going to positive infinity, and as x is going to negative infinity, your y is going to negative infinity. Okay, so that's for a cubic function. Absolute value function we did. The rational function we looked at, but we didn't go full in depth. We'll do that next time. Square root function we did. And here we have a floor function or a ceiling function, and I'll show that one really soon. So the idea is, let me do the first one right here. Let's just look at a constant function. It's really not that bad. The idea is, if I have some, take a second and have this in your notes. If I have, let's say, f of x equals c. So c is any real number. So think of any number on the number line. If this is 0, what's your favorite number? Let's say a lot of people like the number 7. Let's say f of x equals 7. What does this graph look like, right? So here, the idea is you go to the y value of 7, and it should just be a straight horizontal line just like this at y equals 7. And if you wanted to see what is the reason why, the idea is if f of x is equal to 7, then what are you doing? Like, what is f of 0? What this function means is any number I put into the function, it just becomes 7. And that's it. So like here, if I plug in 0 into this function, I get a y value of 7. If I plug in f of 1 into the function, I get 7. Any number I plug in, I just get a y value of 7. So the idea is, if, let's say I'm at negative 3, right? Negative 3, negative 3, 7 is a point here. Negative 2, 7 is a point here. Negative 1. Like, notice I'm just making a horizontal line like this from negative infinity to positive infinity. And this is my graph. Let's say if I had f of x equals negative 3, for example, if I wanted to draw this graph, f of x equals negative 3, I just go down to negative 3 on the y-axis, and then bam, this is the graph of f of x equals 3. I'm sorry, negative 3. Okay, so that was a constant function. Here, the other function you probably have not seen. It's not a very common function, but this is a floor and ceiling function. So let me get the notes for this one. Here, take a second and pause the video to have this in your notes. A floor and ceiling function, okay? And here there's a little mix-up on the graph. Here, for the floor function, this is the symbol that it looks like. This is the graph. And for the ceiling function, this is the graph, right? So take a second, have this in your notes, and I'll go through it, right? Let's say you pause the video and you want to go through it. A floor function is the greatest integer that is less than or equal to x. A ceiling function is the least integer that is greater than or equal to x. So what on earth does this mean? Here, let's take a look at this diagram over here. Let's say I wanted to do the floor of 2.3. So notice that the way you would show it, right? Like if I have floor function of x, notice this symbol here, right? Like if I show what is the floor of 2.3 and I have it like this, what this is telling me is, where is 2.3? On the number line, 2.3 is over here. Which is the least, what is the small, the less of an integer of 2.3? or what's the least integer from 2.3? It just basically just goes to 2. So the floor of 2.3 is 2. But if I said, hey, what's the ceiling of 2.3 like this, it goes to the greatest integer that's available between over here, and that is at 3. And that's all it really does. Basically what it does is it just takes any number and it either rounds it down or it rounds it up to the next greatest integer or smallest integer. So why don't you pause the video and take your time and find the floor of each of these values and the ceiling for each of these values, right? Yeah, so if you were to take the floor of negative 1.1, where is negative 1.1? It's over here. This would be negative 2, right? Because negative 2 is the smallest integer. It's not negative 1. Negative 1 is higher. So the ceiling of negative 1.1 would be negative 1. Here, the floor of 1.01 would be 1, and the ceiling of 1.01 would be 2. This one should be 2, 3, negative 3, negative 2, 0, 0. Right? If you're at an integer, the floor or the ceiling of any integer is just the number itself. Okay? And the way the graph of it looks like, we're not going to go too in depth in it, but a floor function, notice that when you see this graph over here, notice that if I have any rational number that's here, basically the floor function just goes down while the ceiling function is going up, and it kind of looks like a little staircase. Okay, so this is more for when you take computer science. This is a really helpful function within computer science. Okay, let's move on. So we did this. What is game plan for today? So let me get rid of these. Okay. Here, take a second and have this in your notes. And the game plan or the goal for today is this lesson we're going to learn how to shift, stretch, and reflect these parent function graphs. Okay, and algebraically, how do we do it? So what I'd like you to do is first, as a review, have this down, and what does x squared look like? Right? What does square root x look like? What does what does absolute value x look like? Square root x, and x is 3. What do these graphs look like? Take a second, pause the video, and draw them out. Right? You know, for x squared. So if you want to see how it looks like, x squared looks like this. Absolute value of x looks like some v right here. Square root x like this. X cubed is just like that. Okay? These are what these graphs look like. And what we want to do is we want to shift these graphs around. So what on earth am I talking about? Let's take a look at this example here. Take a second and have it in your notes, right? Here, the idea is, let's say we have the function x squared, right? How can we take x squared and make it shift up 5, down 5, left 5, right 5? And algebraically, how are you doing it? So if I have x squared, for example, x squared looks like, let me get the correct color. X squared looks like this. That's x squared. Happy face. Now, what do you have to do to x squared to make the graph go up 5 units? Down 5 units, left 5 units, and right 5 units. What do you think you would need to do? Let me get my calculator over here. So let's say if I have this, right? So let's say if I wanted to graph y equals x squared, right? So the graph of it looks just like that. Now, what would I have to do to this x squared to make it go up 5, right? Let's try this. I would say x squared plus 5, and then voila, notice that it's basically the graph just 5 units up. So notice that here, hold on one second. Give me a message, my apologies. Where was I? Oh yeah, okay, so here we had x squared plus 5 makes the graph go up 5. Okay, so then also, if I wanted to go down 5, it'll be x squared minus 5. Now, the tricky question is, what would I do to x squared to make it move left 5 and right 5? Pause the video and try and think about it. What would you have to do? And if you want, you could go to a website like desmos.com or something. It's like a graphing calculator, or if you have a calculator, try and plug in certain things, certain functions into your calculator to make this x squared graph move left 5, right 5, okay? So yeah, let's say you pause the video and you tried. The way you would do it is it would be parentheses x plus 5 squared. This would move it left 5. So let's just take a look. If I have this and I wanted to zoom in, this is parentheses x plus 5 close square. Bam. And notice that that made the graph go left 5. And then what do you think it would be right 5? It would be x parentheses x minus 5 squared. Makes it move right 5. So it feels weird that, like, when you take a look at this, if I say plus 5, it feels okay that it goes up. And like if I say minus 5, it feels okay that when it goes down. If you see plus 5 over here, your stomach might tell you, oh, it has to go to the right. But notice that when it's inside the function, it has the opposite effect. And the plus 5 on the inside actually means left 5. And this means right 5. Okay? So yeah. All right, so let me zoom out of this. And let me go to this part of your notes over here for you to have down. Here, for transformations of functions, let C be a positive real number, and vertical and horizontal shifts are in the graphs are as follows. So this is vertical shifts, right? And these are horizontal shifts. So if I want to move any graph up C, whatever C is, then it's going to be f of x plus C. If I want to move it down C units, I go f of x minus C. And notice that the outside part is controlling up and down. But if I want to move it left and right, if I want to move it right, it's going to be minus C in the middle. And if I want to move it left, it's plus C inside the function on the graph. Okay? And here what we're going to do is we're going to do a few questions together just so we get the feel for it. So let's take a look at, so I'm assuming that you copied this down, right? Okay, so let's do some examples together. Let's take a look at this. Here, how is the graph shifted? What will the graph look like? Okay, so let's take a look at this one over here. If I take a look at question number 1, take a second and write it down, right? Here I have parentheses x minus 4 squared plus 5. How will the graph shift, right? How will the graph shift? Okay, because the original function, the OG, is x squared, right? This is the original function of x squared. Right? Now it's saying how is x squared going to move in this example? Notice that if I have a minus 4 over here, it's going to be right 4 up 5. Right? Because the inside, and here you could write it over here if you want, inside goes left and right, while the outside shows up and down. Right? So here, because it's minus 4 on the inside, it's going to be right 4 up 5. So then here, I'm going to go 1, 2, 3, 4. 1, 2, 3, 4, 5, and then bam. This is how the original pink graph of x squared gets shifted 4 to my right and 5 up. And that's what this is how the graph will shift. What I'd like you to do is try and do question 2. Pause the video, right? Have this one down. Here, this is absolute value of x plus 3 minus 4. Take a look at question number 3. How does the square root of x plus 3 shift? And how should it look like? And this one would be x minus 1 cube plus 2. Okay, so pause the video and try and draw what they will look like. Draw what they will look like and how does it shift, right? Actually, you should probably write how it shifts first, then draw it out, right? Okay, so let's see. How will this one move? This will be 3 left, 4 down. And notice that it is an absolute value function, so let's say 3. The original absolute value will look like this, like some v. Right? So it's going to be 3 left, 4 down, and the vertex of this gets right over here, and this is your new graph. This is shifting the original absolute value x 3 to my left and 4 down. Okay. Next one over here. Square root of x plus 3. This is going to be 3 left, 4 up. Right? So it's going to be 1, 2, 3, 1, 2, 3, 4. So remember, the original square root of x looks something like this. That's the original. And the transformed version here will just be 3 to my left, 4 up, and something like that. Okay. Here, for the next one, x cubed, what does the original look like? Something like this. Okay. Now what are we going to do? This is going to be 1 right, 2 up. So if this is the center, it's going to be 1 to my right, 2 up. So it kind of looks like this. And that's how the pink graph, or the original graph of x cubed, gets shifted 1 to my right and 2 up. Okay. The second part of this video, I'll show other reflections within the x-axis. So I'm going to break this video into 2 parts. So yeah, I'll have another part very soon. I'll see you there.